Today I'd like to look at basic pulley systems and a simple application for pulleys. Now what is a pulley? Well, a pulley consists of a wheel and a rope. The wheel and the rope can be used to move a load with a force. Let's call it like an effort force. And this pulley can be fixed to a static wall, for example. I'm going to go over three different pulley systems. One is the fixed pulley system, which I've outlined here. Another is a movable pulley system, where you might have a static wall, you have your load, and you have the pulley attached to the load, and the rope running through it with your effort force. And another is a compound pulley system, where you have your static wall, you have a fixed pulley, a moving pulley attached to your load, and you can have the rope running through it with your force. Now let's look at each individually. So in our fixed pulley system, we're going to make a couple of assumptions here for all of our systems. One assumption is that the pulley mass is negligible, or zero. Of course, this isn't the case in the real world, but if our load is extremely heavy and the pulleys are quite small, they can be negligible in our calculations. Another assumption we're going to make is that the friction forces on the pulley is negligible. That would be, for example, maybe the bolt bearing friction, or if the rope slips or any kind of friction in the rope, that would also be negligible. So in this case, with the fixed pulley system, if we have our force of effort here, that force is going to be translated through the rope and be pulling up on the load. So let's call that FL. Now in this case, that force is constant through the rope, and it's a 1-to-1 ratio. So we're going to say that the force of the load is equal to the force of the effort. So any kind of force, if you apply a Newton or 10 Newtons or whatever it is, that force will be directly mapped to the load as a lifting force. Now if we were to look at the movable pulley system, we have our load, and we have our rope, and we have our effort here. Now if you were to look at the forces applied on this pulley, you have your effort force going up, but that effort force, again, is through the entire rope and is also pulling up on this direction. So you actually have 2 times the effort force pulling up. So in this case, the F of the load is 2 times the force of the effort. Now this will give you mechanical advantages and benefits. Of course, the force in this direction is a little awkward. If this were a real-world example, then a compound pulley system might be beneficial. So let's say you're standing over here on the ground, and you can redirect that force with another pulley. So let's have the load, the rope running through and back down. So in this case, you have your force of effort going through, and you have 2 Fe here, and that would be equal to FL. So we have 2 Fe equals FL. So it gives you the same mechanical advantage as the movable system, but it's redirecting the force. Now, one potential application for this is, let's say that you're out in the woods, you have an ATV or some kind of off-road vehicle, and it has a winch, and you're stuck. Now you could have a tree out in the distance, you could put some kind of tree saver on it or anything, attach a pulley, and let's say you pull your rope, or in most cases a winch would have a cable, through the pulley and then attach it to yourself. Now, if your winch has a certain capacity, whatever force of the winch that's capable of, it's actually going to have twice the application here. So you'll be able to get 2 times the amount of effort out of your winch, as opposed to just connecting it directly to a tree. If you had your tree and you tied it directly to the tree. Now, of course, you can even put this further let's say we had 2 trees out here, or even a single tree, but you attach a winch to that tree and attach a winch to your vehicle. So let's say that's our winch, or sorry, a pulley. You have a pulley on this side, pull it through and attach it. Now you have 1, 2, 3 times the force that your winch is capable of pulling. So this is a quick and easy way to apply a pulley system. Of course, pulleys are used in cranes. You have all kinds of different pulley systems that get more and more complicated than what we just went through. But these are the basic principles of how a pulley works. If you have any questions, let me know, and have a good day.